Okay, so I put up post to summarize what you're doing for Tuesday. You got your final project idea, mini paper. You're handing in one per group, and then you're individually. You're each doing critical précis number 3. And the 3 readings that we did for the semester are build. You're going to build from those main ideas when you're thinking about your your uh, your project for your teaching plan. Okay, so as you're building the activities and the visuals, it's all with the premise of these things we've learned in the readings. Okay, so if you go over to course project, we talked about this last time, but there it is. Hopefully you started thinking about what idea you want to do, and so the end of class today, you'll have some time in your groups to keep working on that, and then can give consultations to the groups. I can walk around and answer any questions that you have. So probably the most challenging part of this will be number 2. So in order to explain the understandings your students should have, you have to have a really good understanding of the topic and what's important about it, right? From a conceptual perspective instead of a calculational perspective, okay? So that's the challenge to this. Most of the work that you're going to be doing for this proposal will probably be on number 2. Once you have that, then number 3 shouldn't take too long. I mean, that's going to take some work as well. But number 3 should flow out of the understanding of it. So what are the kind of a large-scale outline for your 3 days that you'll be teaching? Okay. So some groups have asked if more than one group can do a similar topic to another, and that's fine. So you don't have to like stake claim to a certain topic. Okay. So there can be overlap, and we don't want every group doing the same thing. So, but that usually doesn't happen. Okay. So, but if two or 3 groups are doing a very similar topic or module, then that's fine. But then what you produce will be different, of course, right? What you come up with will be different. Any questions on your final project? Or this assignment, not the final project, but just the proposal. This is just the proposal. And like I said, you'll get in your groups in the second half today, and I'll just walk around and answer any questions that you might have. Are we good? Okay. And then, like I said, this reading is the shortest of the 3, and so the critical précis, it shouldn't be long and involved. And my experience is the students really like this article. Okay. Last chance before we do a little activity today. All right, so I got something let's do something 3D today. So in GC, you can do all kinds of 3D imaging as well as 2D. And so just like X and Y are the kind of the default prompts in GC to open up or display in the XY plane, Z will prompt GC to open up the 3-dimensional view of things. So, for instance, you can open up a window and say Z equals X squared minus Y squared. Giddy up, right? Okay, so, and then to make it, you just hit, is it control? Yeah, so to change it, I don't know if that's also in PC, but to change just the size, you hit control and then just with your mouse pad or your trackpad, you just kind of drag with it, you hold control and drag, and that can make the axes the right size. What I like, it's really helpful, is transparency. So if you go to graph, use transparency, that helps you to see a little better sometimes. If you drag it and then click, it's kind of hard to control. You can get it to spin. And there's something about spinning it that really helps you. Like sometimes when it's fixed, you can't really see what you're looking at until it starts to move a little bit. There we go. And then you really can see what you're looking at. That takes some practice to get that spinning to work the way you want. And look, pretty soon it's not going to be spinning the way I want.
It's like in the space where you can't choose the axis.
Is it coming back? Oh, it's coming back. Okay. So this is the idea. So if z is if any character is a dummy variable in a function, it won't prompt graphing, right? But if it's not a dummy variable in a function definition, then z will open up the three-dimensional coordinate system. Okay. So let's look at this. I've got a curve here. So I've defined f as f of a equals a squared, and g of b equals sine of 3b. Okay, so normally, like in Calc 3, when you look at the 3D axes, you look at it this way, x coming out towards you, and y to the right. But for this particular activity, I think it's nice to kind of make x and y this way because it feels a lot more like the standard coordinate system. So I'm showing y here. Wrong window. Let's try this one. It just worked a second ago. Why isn't this working? Let's try this one. There it is. Okay. So I'm showing y and x here, and of course z is up. So does it make sense why I'm choosing this alternate way of looking at it? Because now x and y is more traditional to what you're used to in 2 dimensions. Okay, so the first question is, so I'm displaying, and I can, again, moving it is kind of what helps you to see what you're looking at. So relative to x, y, z, the functions f and g, what is being represented here? So relative to f, g, and x, y, and z, how would you define what I'm showing? So you're not. So in this, you're not working in GC in this activity. You just be answering my questions and doing so. You'll need some paper, you do some math, but you're not going to build this until we're all done. Okay, so you'll build this when we're all done. So don't try to reproduce. Rather go along with my questions. And the first question is, relative to x, y, z, the functions f and g, what am I showing? What am I showing? What's the mathematical representation of what I'm showing? Talk. Trying to get it just to spin. Let's try it again here. Finger slipped. This is really hard to do. There we go. Are you going to be able to see that? No, I'm not. That's no good. Okay, so Tamisha, what'd you guys say? Relative to x, y, z, the functions f and g, what am I representing here with the blue curve? Try to figure it out. You guys still thinking about it? Okay.
I was kind of confused because you're only representing f, you're not representing g.
I didn't say it didn't have to say it had to be with all of them. I just said
Okay.
those are your choices. X, Y, Z, F, and G. What's being represented? So you don't think G is involved here?
G in this, yeah, I don't see it involved here.
Okay. So what about X, Y, and Z?
It's just x squared on the
Okay, so how would we mathematically then, so you say, so is f involved?
Yeah, it's f of x.
F of x. Yeah? What is f of x? Y. So there could be z equals f of x, and there could be y equals f of x. So that's an important distinction, right? So now we got two variables that could be f of x. So are we in agreement? Y equals f of x? Okay, good. All right, so I'm going to pick this x value right here. I'm going to call it x naught. Okay? So these are kind of warm-up questions. All right, so then I'm going to take a segment right to there, and I want to mathematically represent that. So look at that, even lying on its side. Okay, so mathematically, using the symbols and notation I gave you and the definitions I gave you, can you represent that length right there? Represent that length. Go. And do it as many ways as you can. So maybe there might be more than one way. Represent that length in as many ways as you can. A way, or yeah, what you going with? She wants f of x naught. Is that one way? Okay. What's another way we could represent that length? Do you guys know something different? What's that? He wants x naught squared. Said, oh, snap. Okay. Any other way to represent that length? It's so easy, it's hard. What?
Could you f of x not minus f of 0?
Not f of 0, right? I guess you could, because in this case, f of 0 is 0. But you're saying what's, yeah, so 0, you're thinking f of x naught minus 0 is what you're thinking.
Yeah.
It happens to also be that f of 0 is 0, but that's only just coincidence. So yeah, you're thinking of a change, right? The change from there to there. It would just be 0, not f of 0. Yeah?
You can also do the distance formula, and it would be the square root of f of x naught minus 0 squared.
Okay.
X naught minus 0.
So that's just kind of taking f of x naught and making it into a complicated, like.
Yeah.
But you're right, that would be true. It would be, yeah. So I'm thinking simpler, not more complex. Yeah. Is that a hand?
No.
No, that's a twirl.
Twirling my pencil.
Okay, so what coordinate is it? It's y, right? Yeah, so that's a valid way to say it too. It's just the y coordinate, right? What's that? Yeah, sure. So yeah, it's not every y, right? It's the y for x naught. So here. This is a really good point, right? So what's the advantage over function notation to just saying y? Yeah, so y kind of represents like every y value, right? And so the f of x naught, we know exactly what y value we're talking about. So we might say why not? The y corresponding to x naught. So that might be a little better. Okay. Warm up. All right. So now check this out. I'll see if I can. So for the red curve, okay, I asked the same question I did about the blue. Relative to x, y, z, f, and g, what represents the red curve? Relative to x, y, z, f, and g. Go. Putting y into g to get z. Is it right? Okay, so here's a question. How do you know it's y that we're putting into g and not x? So how do you know it's not x that we're putting into g to get Are we saying z is the dependent variable of the function g? Are we in agreement about that? Z is going to be the dependent variable of the function g. Now the question is it x or is it y, and how do you know? So there's a way you can know whether it's x or y. You want another minute or two to talk?
Yeah.
Go.
No, but that's the way it looks.
Maybe.
Wait, what are you saying, Melanie? Yeah. I don't, that's weird though, because that's just the sign. The sign is always between. I still think we should put X. Do you think this is Y? I still think if you put X in A, then X is Y.
Here's a hint. What can you say about these x values? Less than. Here's your hint. There's the hint. What does sine look like?
Right? So I think sine of X squared.
What about from if you go in the negative direction? Down first, right? So this is how you can tell if it's g of x or g of y. You guys come up with it? Why g of y? Henry. Okay, that's one way. Okay, that's one way to think about it. All right, but okay, and then what about what's happening here? So Oscar, you want to talk about that? Okay, so how does that help us to tell what it is? So in this graph, it's not really the sine graph, right? Because when you go into negative x territory, it goes back up. It's like a mirror reflection. So how does that work? How does that tell us what's going on here? So why does that make sense based on whether it's x or y? Okay. Anybody else? Ron, you want to share what you came up with? Yep. Right. So if when x was negative, it's depending on x, then where would sine go? Into positive or negative z territory? Negative z territory. Okay, but instead? Okay. Right. So y is positive this way, but y is also positive this way. So it's going to be like heading in the positive direction. You're going to get the same thing that you would going this way, right? So yeah. So you're getting sine of positive values, and y is positive here, right? Instead of sine of negative values, which would give us negative z. Wait. Go ahead.
Well, okay, so technically you're saying we still are doing f of x and putting
so then what is y? Yeah, we said that before. F of x. But we were just answering the question from a standpoint of z as a function of g. What is giving us these values of g? Was it a y coordinate or an x coordinate on the blue curve? It has to be y because we're heading, z heads positive in both directions rather than heading negative for negative and positive for positive. So it's heading positive in both. That's what y does. It's y is positive in both directions, giving us positive z in both directions. Make sense? Okay, so now this point right here. We're going to call that, of course, the x value of that point, I'm going to call x1. And I want you to use good notation to represent the value of, or let's see. No, let's see. So now, actually, we want you to find the actual value. The actual value. And then represent it. Then represent it with some symbols. You're not going to do this in your head. You're going to need to be writing, okay? So, okay, find the value of x1. It's the x coordinate of that intersection point. No, let's not do. Let's for time's sake, let's move on to the next thing. Okay. Oh, anyway, so let's Angela. I want you to. Can you walk us through how you got x1?
Yeah. So we knew that the parabola is on the xy plane.
Mm-hmm.
And so where they since the sine curve intersects with the parabola,
Yep.
that means that it intersects at 0, or sorry, z is 0. So then you have to set sine of 3y equal to 0 to find what y is at the point of intersection. And then we know that sine is equal to 0 at pi.
Okay.
And so you set 3y equal to pi.
And why is it pi and not negative pi?
Because on the unit circle, sine is equal to 0 at 0, pi.
And negative pi. Right.
Yeah.
So why is it? But there's a reason. Why is it pi and not negative pi? Yeah.
Would that be because later on when we're trying to find our x value, you end up with you need to end up with square root of a negative number?
But there has to be, coming from where we've come, there has to be reasoning from making this deduction that 3y equals pi. So it's not about what we're going to do later. It's about making deductions one step at a time. Why now do we say pi and not negative? Yeah, Chloe.
Because all the outputs of y are positive.
Right. Right, because so if y is positive, then it's like we're heading up right on the sine curve, right? We're heading to the right in the positive direction. Okay, good. So 3y equals pi, then, yeah.
Oh, okay. So then we have y is equal to pi over 3.
All kinds of. It doesn't work with that program, but I didn't have much on there, so okay. Here we go. So this is our point. All right, so you said z equals 0.
Yeah, and then we had sine of 3y equals 0.
Okay.
And then we set 3y equal to pi.
Okay.
And then, so then you have y equals pi over 3. And then from there, we know that y equals f of x.
So that right there is from the last thing we did, right? So that's that distance right there. Okay.
Yeah, so then we know that y equals f of x.
Okay.
So then we're going to set pi over 3 as y, and then we're going to equal it to f of x sub 1.
Right.
And then we know that f of x is x squared, so we're going to do pi over 3 equals x sub 1 squared.
Mm-hmm.
And then we're going to take the square root, and then you get the plus or minus the square root of pi over 3 is equal to x sub 1.
Okay.
And then because it's on the left side of the x-axis, it's on the negative side, it's negative root pi over 3.
I think all the tables kind of arrived at this. So Shanley, in the last step you squared and says, wait, no, you figured that out. I remember you figured that out. Okay. I think all the tables got it. If it's right, the way if your way is mathematically sound, it's fine. Do you want to share what you did?
I just knew that we were determining our z as a composition of functions.
Okay.
G of f of x.
Okay.
So we said that z is equal to g of f of x1 is equal to 0.
Okay.
So then we know that g of f of x1 is sine of 3 times x sub 1 squared.
Sine of
Or 3 times x1 squared.
x1?
Yeah.
F of x1. Shouldn't that be y? That should be sine 3y. Because g is a function of y, right? So you could have y here or f of x1. Do you want to keep going? How did you get it?
I don't know. I ended up with the same answer. I just
I mean, this is
solved for x1 with sine of 3x1 squared.
right. Right. So yeah, x1 squared. That's fine. Sine of 3x1 squared. But you said x1. Oh, you did? Oh, I didn't hear. Sorry, my fault.
It's okay. And then just solve for x1.
Yeah. So it's just showing everything along the way when Angela just did it. Just was looking at the piece at a time. So you're doing the same process. Other questions, comments on that? Can I erase? Yeah. What if you don't know what your z value is? x2. Okay, so I want you to represent that vertical length, which is based on x2, in as many valid ways as you can. Represent that vertical length in as many valid ways as you can using f, g, x, y, and z. I should say and or. F, G, X, Y, and or Z. Okay. Let's just go around. All right, Morgan, what was one that you came up with? G of f of x2. Awesome. Okay. So we're saying, what is this? And what is all these are going to equal what? What would be the z2? We'll call it z2. Okay, so z2 is g of f of x2. So Daphne, you got another one? G of y2. Good? I should ask before I write, right? Okay. All right, you guys. Sing. What's another one? G of x2 squared. Let's see. Ryan. Melanie. Stanley. Jose, got another one? Josh. Okay, that was the first one we had. Thank you. Thank you. Is that right now? Okay, so is there anyone? Did you come up with any more? Who had the big? Ron, was there another one? Okay. Anyone come up with another one? Anyway, okay, so you guys all picked up really quickly on the fact that this is about composition. So notice that g of f of x2 is equal to, this is good that we landed on this one last, right? I'm going to write it again. Sine of, so really any z, right, is g of f of x. And that ends up being sine of what? 3x squared. So isn't that its own just single function in its own right? So let's name that one h, okay? So we'll say h is sine of 3x squared. Okay, so which is the composition? Is that the composition, or is h the composition? Which is the composition of g and f? Is it z, g of f of x, or is it h of x, sine of 3x squared? Where did we land? H of x. Genevieve says both. Stanley says both.
I mean, the equal sign says that they're all equivalent, so if one is, they all are. Well, in terms of value, yes,
Both. Both. So it's just two different perspectives on the composition of G and F. Here is, what we've been looking at in the 3D rendering of it is which version? The G of f of x or h of x? What have we been looking at as we've been looking at? Which version have we been looking at? We've been looking at G of f, right? Because we're thinking about an x coordinate giving us a y coordinate, that's the dependent variable of f, and then that giving us a z coordinate. So how can I get a view of h of x? How can I get a view of h of x? What's different about h of x from g of f of x? Yeah, Maureen. Would it just not have the blue? It would just be the one question? Okay, so what do you you saying? By not having the blue, what are you saying?
Well, with the way we're computing that z equals g of f of x, you have to have f of x.
Okay. And what is f of x? What is f of x? Bypass the y. How can I get a view of bypassing the y? Okay, now in GC, graph. So in GC, do y equals sine of quantity 3x squared. In GC, do y equals sine of quantity 3x squared. What was h of x? That was it, right? What happened? What happened in y? So our composition, this version of the composition, sine of 3x squared was what? Z as a function of x. We eliminated the middleman, right? We took out y. And what happened when you graph that? But we're still looking, okay, my version is still this. It's still this. It's just a view where you only see x and z. When you only see x and z, right there, somewhere there. Then we're looking at z equals h of x equals sine of 3x squared. Was there at least an internal? Oh, this is so cool. Did you see what's going on? Okay, and then what did we say? What was the blue curve? What was the blue curve again? And what was it? What did it relate? Y equals f of x or x squared. So just 1 second, I need to, I'll do this. Okay, so I took out the blue curve, but what did we say? Y equals f of x equals x squared. How can we see that in this graph? And how do you want to look at it? That's better, guys. That's better. Still a little bent there. That's the best I can do. Okay, so if I eliminate the view of z in that in the composition, and I just look at y and x, I'm going to see that relationship of y equals f of x, just x squared. And finally, what's the last one? We said z could also be written what? Yeah, so z was what? Z was a function of, what function of what? G of, and what function is that? Sine of 3y. But only for positive values of y, right? We only got to see this for positive values of y, so what I'm going to do? Why do we only see the positive version? Because y is only positive when you you put x into x squared, you're only getting positive values of y. So we get the positive values for sine of 3y when we look at the same thing from the x direction, or the y direction, x direction. Okay. So again, when you're looking at when you can see all three, you are looking at z equals g of f of x. When you look at just the x and y coordinate, you're looking at f. I showed you x squared. When you look at the z and x, you're looking at that one, the composition simplified, right? And then when you look at z and y, you see that. Okay. Yeah, so that's going to be a surface. So now your task is to build this little thing here. But the key here is that these aren't surfaces, these are curves, okay? So how can we get to sketch curves in 3D space rather than a surface? Okay, so then Kendall had a good thought, and that was, can you also display the h function just in, you see the purple? So the red one was the one you were working on. And then what about the composition h without y displayed in its respective plane? See that? So that's the h function displayed in its plane, so that if I look straight down y, I should match up. Something like that. So after you display the red composition, can you display the composition, what? Eliminating the middleman, right? So without the y value. So you just ask yourself, what's true about all those points? It's not hard.